Hi, my name is Marcus Jones. I'm from Canada, where I studied engineering and physics. I then ended up in Austria, in the city of Vienna, where I worked as a researcher and an engineering consultant in the field of energy and sustainability. During my project work in Vienna, Austria, I was finding myself more and more drawn to programming and data analysis. And with the new topic of machine learning and data science becoming more and more popular, I decided to investigate further. This is how I ended up in Berlin, where I'm doing the Data Science Retreat program for the past 3 months. So for my project here at Data Science Retreat, I decided to implement an autonomous driving system on a small-scale radio-controlled car. What I did was I took out the controller from the car itself and I replaced that with a Raspberry Pi. I then added a camera so that the Raspberry Pi is able to take images, and then on the software side, I implemented a TensorFlow project on the Raspberry Pi itself. On TensorFlow, I'm running and training a convolutional neural network. Convolutional neural networks are actually revolutionizing the field of image and video recognition, and they're very good at picking up features in the environment to train on. So with this system in place, I was able to successfully train and then autonomously drive this car. So the car was actually navigating its environment autonomously without any human input. So once this system was in place, I then noticed that the car was actually making some steering errors in certain areas of the track. So it's actually quite difficult to understand, in some sense, what the network is seeing. So I stumbled across a paper which describes a process which could help us to understand this network itself. The process is called deconvolution, and in a sense it's taking the convolutional layers and going backwards in order to create some type of visual representation of the activations of the network. So with this system, I then use this as a mask over my video frames, and I'm able to then visualize where the network is currently activated, or in other words, what the network is actually understanding about what's important in the world. So using the system, I was able to then highlight the areas of the frames which the network was seeing, which were causing confusion. For example, the glare from a window was causing the network to steer into a wall. So by highlighting this visually, I'm then able to diagnose the error in some sense. I could then perhaps treat this at a hardware level or a software level to try to solve this problem. So I consider this project a great learning experience, and I also consider it actually more of a beginning. There are many, many ways which we could take this project further. For example, we could add further sensors to the car. We could add, for example, ultrasonic or radar sensors so that the car has a better understanding of the world. We could also try to optimize the software layer. This means to maybe add more network layers or to do some hyperparameter optimization for the network. I've had a big success here at the Data Science Retreat, and I look forward to continuing this work in the future. I have a unique combination of technical expertise in engineering and project management. I also have a history of entrepreneurship. I like to work best in challenging and dynamic team environments, and this allows me to solve problems creatively and innovate in new directions.